Hi, future doctors. Welcome to the next class. We discussed Atwood mission and the object placed on horizontal surface, and another object is hanging vertically. So M1, another object suspended vertically. M2. So we discussed what is acceleration M2g by M1 plus M2. Another one, what is the tensional force M1 M2g by M1 plus M2. And what is the thrust acting on this? In Atwood mission, thrust means we said, so this is T, this is T, thrust is going to be 2T. Now this is T, this is T. What is the thrust acting on this? T. So resultant T, what is the angle here? 90 degrees. Therefore, thrust acting on this is going to be root T square plus T square, root 2 T. At the time you will get here, thrust is going to be root 2 times of M1 M2 by M1 plus M2 into G. So this is about two objects. One is placed on horizontal surface, another one is hanging vertical. And next one object is placed on inclined plane. One object is placed on inclined plane, another object is suspended vertically. See here, this is going to be M1, another object is suspended vertically M2. So now M2 is greater than M1, let us assume. M2 is moving downwards with acceleration A. M1 is moving upwards with acceleration A. So what is this acceleration and what is the tensional force developed in this string? Okay, if you resolve this weight always will act downwards into two components. So this is making theta M1g cos theta. This is going to be M1g sin theta. This M1g cos theta on inclined plane is balanced by normal reaction. So normal reaction on inclined plane is always M1g cos theta. Now this is the inclined plane whenever we are taking, this is horizontal. So if we are making it inclined plane like this, if you place any object like this, then it will be coming downwards. Slowly it is coming, see, it is coming downwards along the inclined plane. So in this direction, how much force is acting means M1g sin theta, isn't it? So resultant force acting on this is going to be resultant force acting on this M1g sin theta downwards, tensional force upwards. Just I am drawing free body diagram. This is M1g sin theta, tensional force upwards, it is moving upwards. Therefore, net force is T minus M1g sin theta. Then M1a is equal to T minus M1g sin theta. Then T is equal to M1a plus M1g sin theta. Call it as equation number 1. So another equation, this weight is going to act M2g downwards. It is moving downwards means what we said formula downwards means M2g minus M2a. That is equation number 2. So downwards means M2g minus M2a plus minus will be coming. Upwards means plus will be coming. Equate 1 and 2. What is equation 1? M1a plus M1g sin theta is equal to M2g minus M2a. So you can rearrange this M1a plus M2a equal to M2g minus M1g sin theta. So M1 plus M2a is equal to M2 minus M1 sin theta into G. So acceleration is m2 minus m1 sin theta by m1 plus m2 into g. This is the acceleration formula. Now what is the tensional force? Tensional force means put this equation in equation 1 or 2. So any one you can take. So 2 if you are taking m2g minus m2a. m2g minus m2a. So if we substitute m2g minus m2, what is acceleration? m2 minus m1 sin theta by m1 plus m2 into g. So what is LCM? m1 plus m2. So now after taking LCM, m2 into m1 plus m2 g minus m2 into this one you can write normally m2 minus m1 sin theta g. So if you expand this m2 m1, first one m2 m1 plus m2 square g minus m2 square g minus into minus plus m1 m2 sin theta into whole g divided by m1 plus m2. If you cancel these two, so if you are taking m1 m2 LCM means common 1 plus here sin theta divided by m1 plus m2g. This is going to be tensional force acting. Okay, so this is T. Now what is the thrust acting on this? Thrust means you should come to know this angle. What is this angle? This is theta 90. Therefore this angle is 90 minus theta. So on the inclined plane, if it is 90 minus theta, T. So thrust formula root t square plus 2 tt cos 90 minus theta. This is the formula for thrust. Now we got total 3 equations in a fluid machine. So how to remember logically? I am saying m1, m2. So in another case, m1 is horizontal surface, m2 is vertical. This is m1, m2. In another case, m1 is making theta angle, m2 is vertically angle. So in this case, we got tensional force. So 1 plus sin theta m1 m2 by m1 plus m2 into g. Acceleration m2 minus m1 sin theta divided by m1 plus m2 into g. Denominator not doing any mistake because m1 plus m2. But numerator you can see for remaining these two. So here m2 is making how much angle with horizontal line? It is going to be 90 degrees. m1 is making how much angle? This is also 90 degrees, correct? So m2 among all these cases vertically hanging. Therefore you don't change m2. Now see here theta is how much? Theta is going to be 90. Substitute here theta 90, you will get this equation. For tensional force, if theta is 90 here, 1 plus sin 90. Remaining thing is common, m1 m2 by m1 plus m2 g. Sin 90 value 1. 1 plus 1, 2 m1 m2 by m1 plus m2 into g. Correct? We got same equation at fluid machine. So if you remember these two equations, you can remember remaining equations. Now see what is the acceleration in case of at fluid machine. Acceleration is m2 minus m1. Put sin theta 1 means sin 90 here because m1 is making theta 90 degrees here. Therefore, from this equation m2 minus m1 sin theta equation, you will get m2 minus m1 sin 90 by m1 plus m2 into g. Correct? So in this case, you can see it is making how much angle? M1 is making how much angle with horizontal means theta is 0. Put theta is 0 in this. T is equal to 1 plus 0. M1, M2 by M1 plus M2G. Correct? Same equation you got in this case. Now acceleration. Put theta 0. This term will become 0. Then M2 by M1 plus M2 sin 0, 0. Therefore, we will get G. So therefore, if you remember these two equations, you can remember remaining all equations. Correct? So try to remember like this. It will be easy for us. Thank you.